Welcome to The Explainer. Let's just jump right in, because the EV charging landscape is completely transforming before our eyes. We're finally shifting away from a world where charging just meant plugging your car into a wall at home overnight. Now, we're looking at a massive, incredibly dynamic global ecosystem. It's an evolution that's actively solving the absolute biggest anxieties for everyday drivers, while simultaneously rewiring global supply chains to be faster and a whole lot more sustainable. Today, we're going to explore exactly how this infrastructure is scaling up, from an individual roadside car rescue all the way to multi-megawatt commercial hubs powering heavy industry. It is a truly fascinating evolution.
So, today's explainer takes us on a pretty wild ride. We'll hit the range anxiety problem, mobile charging rescue services, how those mobile charges actually work, electrifying heavy-duty fleets, scaling global infrastructure, and then wrap up with the future of EV power.
All right, let's get into it with Section 1, the range anxiety problem.
It's the ultimate consumer fear, right? Picture it. You're on a long road trip, cruising down a lonely stretch of highway, you're miles from a plug, and your battery is just totally, completely dead. For over a century, if you ran out of gas, someone could just walk over with a jerry can and get you back on the road in 5 minutes. But, well, you can't exactly carry around a bucket of electricity. This one looming fear of getting stranded has held back countless potential EV buyers. It's honestly been the most stubborn bottleneck for mass adoption.
Which brings us nicely to Section 2, mobile charging rescue services. Because established companies are stepping up right now to solve this exact problem. Take the American Automobile Association, for example. AAA is literally deploying mobile EV charging trucks to their members in over a dozen major cities, and they're doing it at no extra charge. If you run out of juice, they don't have to send a massive flatbed to tow you anymore. Instead, they just come directly to you and give you enough of a boost to safely reach your charging station. It's the modern equivalent of that jerry can of gas. And think about why this matters. Having a legacy name like AAA provide this service instantly normalizes the EV experience for millions of hesitant drivers.
And it's definitely not just AAA leading this charge. Major automakers like Volkswagen and NIO, alongside specialized energy software companies like Synop, are aggressively rolling out their own mobile networks. Think of these setups as giant, commercial-grade power banks on wheels. They're highly specialized, fast-charging units that can be dispatched on demand, which completely decouples the charging experience from a physical piece of real estate. So let's look under the hood in Section 3, how mobile chargers work.
To really wrap our heads around this shift, we have to separate the old way from the new way. On one side, you've got fixed charging stations. These are stationary, hardwired to the electrical grid, and you have to physically drive to them. On the other side, we have mobile charging stations. This is dynamic, dispatched equipment offering a charge anywhere, anytime. It's a fundamental shift, you know? We're moving from a pull model where you go to the power to a push model where the power literally comes to you.
And these mobile stations aren't just some temporary band-aid for people who forgot to charge overnight. They sit squarely in the middle of the official EV equipment ecosystem, right alongside traditional fixed plugs and those crazy futuristic wireless charging roads. The consensus in the engineering world is that mobile charging is a permanent, foundational layer of our future power grid. So here's where it gets really clever. Truck mobile charging stations actually work in two distinct ways. Some trucks are equipped with their own massive battery energy storage system. They literally carry the power with them to charge your car. But others don't carry a massive battery at all. Instead, they act as intelligent power routers. Imagine a packed highway charging station on a busy holiday weekend. Instead of cars waiting for hours, these routing trucks just pull up, plug into the main grid or an overloaded station, and instantly split that power to provide multiple extra charging points, multiplying the station's capacity on the fly.
The ripple effects here for both drivers and the power grid are absolutely massive. Yes, it cures range anxiety, but check out the bottom of this list. Mobile chargers can actually store energy during cheap, off-peak hours and then discharge it into vehicles during expensive peak hours. They basically become a giant shock absorber for the power grid. This reduces the need for insanely expensive grid renovations just to handle a few hours of peak demand every day. And at the end of the day, avoiding those massive overhauls keeps energy costs down for everyone, whether you drive an EV or not.
All right, let's go even bigger. Section 4, electrifying heavy-duty fleets.
Think about the immense scale of global shipping. Every package at your door started somewhere like this. At the Port of New York and New Jersey, APM Terminals handles a staggering 800,000 truck visits every single year. Just let that scale sink in. To handle that incredible load without blanketing the whole area in diesel smog, they're modernizing fast. They're deploying 96 zero-emission electric tractors and 34 fully electric gantry cranes. This isn't just replacing a few sedans, this is total electrification at a relentless 24/7 industrial scale.
And the managing director there pretty much hit the nail on the head. Commercial giants aren't just making this expensive leap to meet regulatory emission targets, it's about raw capability. It's about future-proofing global supply chains. By upgrading to highly efficient, torquey electric infrastructure today, they're making sure their operations can handle the compounding cargo growth of tomorrow without being held back by legacy fossil fuel maintenance.
But how do we power all that? That's Section 5, Scaling Global Charging Infrastructure.
1.2 megawatts. I just want to pause for a second and let that number land. That is 1,200 kilowatts of raw power. It's the staggering output of Tesla's newly opened public megacharger station in California, built specifically for heavy-duty electric semi-trucks. To put that into perspective, a standard home EV charger outputs around 7 to 10 kilowatts. We are talking about charging on an entirely different, almost unimaginable level, pushing a mind-blowing amount of current into these massive batteries in minutes, not hours.
And we're seeing this rapid scale-up everywhere. In London, Ionity is opening an incredible 400-kilowatt ultra-rapid urban hub. In Canada, BC Hydro is deploying heavy-duty fast chargers. Kimpower is commissioning a massive 650-kilowatt terminal in Colorado just to charge 28 electric school buses all at once. And in Germany, NG Vienio is building dedicated electric truck hubs along major European freight corridors. This global, high-power network isn't a whiteboard concept anymore. It's literally being poured into concrete right now.
Which leads us to the final piece of the puzzle, Section 6, the future of EV power.
Because of this massive power demand, we are swiftly moving away from simple dumb charging, where a vehicle just plugs in and blindly pulls maximum power regardless of grid stress. We're moving to smart charging. Smart charging is essentially the brain of the whole operation. It relies on cloud-based software to carefully manage exactly when and how fast a vehicle charges. For instance, Hyundai recently partnered with a software platform called Calusa to ensure their EVs automatically communicate with the grid, charging at times that minimize financial costs for the driver and carbon emissions for the utility provider.
And physically handling that incredible, dangerous heat generated by this rapid energy transfer, the hardware has to evolve right alongside the software. Manufacturers like Exacom are now producing advanced liquid-cooled power modules. Just like a high-end gaming PC absolutely needs liquid cooling to keep its processors from melting down, these commercial megachargers require active liquid cooling flowing right through the cables to safely push megawatts of power into commercial vehicles without overheating. It is a phenomenal feat of thermal engineering.
Which brings us to our final thought for today. We've seen an incredible spectrum, from AAA rescuing stranded drivers with mobile battery trucks, all the way up to megachargers powering massive commercial fleets with smart software and liquid-cooled cables. The infrastructure isn't just a stationary dumb plug on a wall anymore. It's dynamic, it's highly mobile, and it's incredibly intelligent. So, it leaves us wondering, as these automated multi-megawatt grids become the standard worldwide, are we finally ready to let go of range anxiety for good and fully trust this invisible, dynamic web of energy? Thank you so much for joining me on this explainer. I hope this journey sparked some serious curiosity about the fascinating electric world being built right outside our doors.